Okay, so here's a lesson on the second part of systems of equations here, where we're going to be looking at word problems. But before we begin, I wanted to show you a little trick. Now remember, you have to be able to do these by hand, these systems of equations by hand, but I did want to show you that your graphing calculator can do these for you. And one way of using the graphing calculator is to check your answers and make sure that they're all correct. So before we get started on the word problems, I did want to show you the trick on the graphing calculator. So what I have here on the left side of the screen is the graphing calculator, so we can sort of see this at the same time. So we're going to look at a typical question. It's all blurry. It was copied and pasted, so sorry it's a little blurry, but you can see the numbers. So here's a problem where, normally we would do this by hand, and if you want to know how to do this by hand, just watch the previous video, and I'll show you how to do this by hand. But today I'm just going to show you how to do it in the calculator. So in order for the calculator to calculate systems of equations, we use what is called matrices. So in the graphing calculator, you can see just below the math button, you'll see matrix there. So to get to that, we hit second, and where it says matrix there, we'll do that. And so, and you can see the button is highlighted in red there. There's a bunch of different matrices that you can edit, but we only need 2 of them. So we're going to go ahead and edit these matrices. We don't need to name them or anything like that. The A, B, C, D is fine. And so what you do is you're going to edit these matrices to put in these values. And so it's going to ask you, it's going to start off with, 1 by 1. And what that refers to over here is basically the length and the width. So you're going to make a matrix for this part. This will be matrix A, and this will be matrix B. So when you're looking at matrix A, you have to say, okay, well, there's 1, 2, 3 variables and 1, 2, 3 rows. So we would call this a 3 by 3 because there are 3 equations and 3 variables. Okay, 3 variables, 3 equations, you get a 3 by 3. So we have to change this to a 3 by 3. So you just type 3, enter 3. And so it gives us this grid of 9 numbers we need to put in, and it corresponds with the 9 numbers that we have right here. So we're going to go ahead and put these 9 numbers in, just like they are. So the first line, we have 4, then 2, then 3, then 2, then we have a negative 3. Don't forget to use the negative sign and not the minus sign. Negative 3, 5, and 6, and negative y is the number there is actually negative 1, and then 4. And so enter, and so we're good. The matrix is good for matrix A. We have we split up all the numbers from their answers. So now we need to make a matrix B that has all the answers in them. So now we're going to go back, and so it's probably easier just to hit second and matrix again, and go over here to edit. And so now we're going to edit B. We put all the variable coefficients into A, and now we're going to put all the answers for each equation into B. So this one, think about it again. Okay, this is going to be 1, wrong one. 1, 2, 3 by 1. We call this a 3 by 1. Now, if for some reason you accidentally put 1 by 3 and hit enter, you'll see that, wait a minute, that doesn't look right. It's supposed to be vertical. It's supposed to be like a column. So you did it backwards. So it is actually a 3 by 1. 3 by 1. There we go. Now it looks like a column. That looks like the way it's supposed to look. And so now we're going to enter the digits in. So we have 12. Negative 7, and negative 3. Okay, so once we have everything in, we are set. we can look at this if we want. We have matrix A and B both in there, 3 by 3, 3 by 1. We're good to go. Now the fun, or so the magic, happens once again. You're going to go to quit, which is just second in mode. You see the little blue there. It says quit. That gets me to the home screen. Now this part is critical. This is the important part where you need to make sure that you enter this in. It'll be the same exact thing every single time, but we want to make sure we enter it in right. So we're going to now we're going to put the matrix into our calculator. So we're going to go back to matrix. And instead of editing, we're going to use matrix A. So you'll just see like an A in brackets there. And then you have to use the inverse button, which is the same exact button as the matrix button, except you're not going to hit second. So it's to the -1. And then you're going to get matrix B. So second, matrix, go down to B, hit enter. A to the -1, B, enter. And there you go. There is your X, Y, and Z. Your X is -1, your Y is 5, and your Z is 2. So if you want to repeat that, go back in the video, rewind it, play it back. If you want to go through that process again, if you want to try a few more other problems, you can. So there you go. Now, once you've mastered this, you don't have to do these by hand anymore, so you can just go right to the answers, which is -1, 5, and 2. There you go. No work, no space, just the answer. Okay, but remember, you have to master that doing it by hand before you can use the graphing calculator. Now, question comes up is like, we're something like this. So this is 3 equations, and there are 3 variables. There is an X and a Y and a Z, but not all the equations have all the variables. So you will always have, in a 3-variable system, an X and a Y and a Z. But when you go to put this in the matrix, for example, the first equation doesn't have a Y. So when you go to put this in the matrix, it'll be 2. Now, since there's no Y, you're going to fill the Y with a 0, and then the Z is 3. In the second equation, you'll see that there is no Z. So you have an X and you have a Y, but no Z. And in the third equation, there's no Y again. So you have a 1 and then no Y and then a -2. So your matrix will go in like that. So anytime that there is a variable missing, you'll just put in a 0 in its place. It also works for 2 by 2s. So you just have to change your matrix to a 2 by 2. You'll just have 2 variables, 2 equations. And then you'll change your answer one to a 2 by 1 instead of a 3 by 1. It's the same exact process. Again, if you want to go back, I'm not going to do another one. You can just repeat the process, watch the video again. This lesson is supposed to be on word problems. So we're not going to do the first one, so we'll do the second 2 here. And with word problems, you do not need to find the answers to these matrices by hand. When doing the word problems, it doesn't matter if you've mastered or not. When doing the word problems, you can use the shortcut. All we're doing here is making sure that you can just set up the equations correctly. So when you are doing number 3, let's clear that out so it's not a distraction. When you're doing number 3 here, you'll see a museum passes. Museum passes cost $5 for adults and $2 for children. One day, the museum sold 1,820 passes for $6,100. How many of each type are sold? This is a standard, word problem, ticket sales, stuff like that. You did this in Algebra 1, but basically you set up the equation for one equation looks like it's going to be like the cost, money. I see money, and then over here I see money. But then I also see types of tickets, adults, children, and then a total of passes sold. So that's going to define your 2 equations. One equation seems to be, or one set of data seems to be just all about money, $5 and $2 for a total of $6,100. We can write that in our equation. So $5 per adult plus $2 per child, that's a C, equals a total of $6,100 that they made that night. The other piece of information looks to be like the type of ticket. So it does say that there are adult tickets and children's tickets, and they did say that they sold 1,820 total tickets. So I could say that all the adult tickets plus all the children's tickets, C, is a total of 1,820 tickets. And so this particular word problem sets itself up for a 2x2. So I don't need to solve this by hand, though you certainly could if you wanted to. Maybe you forgot how to do it on the calculator. But I'm going to go ahead and plug this in the graphing calculator. So again, I go to matrix. So second matrix, there's the fourth button down. Now we're going to edit these because we need to put in new numbers, but also because this is a 2x2. So if we separate this, there's two variables and two equations. So I do need to change this to a 2x2. So you'll see it goes to 4. I'm going to plug in the numbers. So I have 5 and 2. I want to do 5 and 2. The enter button's really close there. And then for A and C, there's no coefficient, so it's just 1 and 1. Okay. Now we're going to do the answer one. So we go to second matrix again, edit. Now we don't need a 3x1 because we don't have 3 answers. We need a 2x1 because there's only 2 answers. And we have 6,100 and 1,820. There you go. We're good. Okay. We can quit, go back to the home screen. So now we're going to put in our matrix again. This is how we get our answer every single time. You just pull up matrix A and then do the inverse of that, so or to the -1 power, whatever you want to do. And then we call matrix B. It's always going to be, your answer is always going to be matrix A to the -1 matrix B. That's how you find your answer. And then when we hit enter, we get the amount of tickets that were sold. So it looks like adults, because that was our first variable, adults was 820 tickets, and children 1,000 tickets. And that's it. That's all you need to do. So just set it up and then use the calculator to find the answer. You don't need to do those by hand. Okay, we're going to do one more. This is another sort of typical word problem for systems of equations, and this is different seats in an auditorium. So let's look at that. Let's set it up. An amphitheater charges $75 for section A, $55 for section B, and $30 for a lawn seat. Think of like, Klipsch, or so I guess it's not Klipsch anymore, but Ruoff Home Mortgage. Same thing, section A, section B, and lawn seats all have different prices. There are 3 times as many seats in section B as there are in A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section? So again, it looks to me like there is a dollar amount, a dollar amount, a dollar amount, and a total dollar amount. So this is going to be pretty typical with these, but that's whenever you see dollars, dollars, so that's going to be one of your equations. This looks to be obviously like a 3-variable equation because I have 3 sections. So it is $75 for section A, and then $55 for section B, and then $30 for the lawn seats. So that's our first one, and then it says the total amount of sales was $870,000. The next one, and I'll use a different highlighter here. Use blue. It looks to be simply like there's also 3 types of tickets that you could buy section A, you could buy section C, you could also buy a lawn section, and the total seats, it looks like, is 23,000 seats. So in section A, B, and C, or A, B, and lawn, there are 23,000 seats. So however many seats are in A plus however many seats in B plus the amount of lawn seats should total 23,000 seats. Now the last one gets a little bit tricky because the last piece of information doesn't really tell us explicitly the equation. It just says there are 3 times as, and let me change the highlighter. This is different. There are 3 times as many seats in B as in A. So this is a little tricky. So I'm going to just kind of write off to the side here. It says there are 3 times as many seats as there are in A. So your first instinct might be to be 3B equals A. 3 times as many seats in B as there are in A. The problem is, if there are 3 times more seats in B as there are in A, then this equation doesn't work. Because let's say, just to give you a small number, for example, if there are 3 times as many in B as there are in A, so if B has 12 or something like that, then 3 times 12 is not, so that would mean that there are 36 seats in A. But it says there are 3 times as many seats in B as there are in A. So what this means is in order for this equation to work, if there are 3 times more in B than A, then 3 times B is not going to equal A. What you have to realize is if there are 3 times as many seats in B than there are in A, then I would need to multiply 3 times A to get B. If there are, just kind of stop and visualize, if there are 3 times as many seats in section B as there are in A, then for this equation to work, if I multiply the seats in section A by 3, then that would equal to the seats that are in B. I know it seems confusing, but just play with some numbers. Just for example, so here's an example. 12 seats in B, there are 3 seats in A. Right, or not, I shouldn't say 3, I should say 4. 4 seats in A. Okay, would you agree that this one right here, this is section B, has 3 times as many seats in A? B currently, right here, has 3 times as many seats as there are in A. So you look at the equation. If I multiply 3 times 12, I do not get 4. But if I multiply 3 times 4, I do get 12. So you have to think about that. The way that it sounds is actually the opposite of the way it should be written. So though it looks like 3 times as many seats in B is as A, just realize it's the other way around. It's actually 3 times A equals B. Now that we have that piece, that's our third equation. Our third equation is this. This is our third equation. 3 times A equals B. Now, the problem is, look at all the other equations. All the other equations have all of the variables on the same side. All of them on the same side of the equal sign. So I do need to move the B over here in order to put it over here. So I'm going to subtract B to this side. So I get 3A minus B, and that'll equal, well, there's nothing on this side, so it'll equal 0. So when I go to put this up here, I'll have 3A minus B. Now in this particular case, there is no C, so we're just going to leave it blank. When you go to put this in the matrix, you'll just put a 0 in its place, and it equals 0. So now I'm going to set up my matrices to find how many seats are in each section. So second matrix, go to edit. I do need to change this back to a 3 by 3 because I do have 3 variables and 3 equations, so 3 by 3. First one, 75, 55, 30, there you go, enter, and then I have 1, 1, 1, 1, 1, 1, and then the bottom one I have 3A, And then B is -1. Now I don't have a C, so it would just leave it as 0. There's nothing there, so I'll leave it as 0. Go back to matrix because I got to put in the answers, which is in matrix B, and this is a 3 by 1. Looks like 870,000, and then 23,000. And the answer for the third one is just 0. So I can go ahead now and solve this. So I'm going to put matrix, let's quit here, go to the home screen. Matrix A inverse matrix B. Enter. And there you go. In section A, there are 1,500 seats. In B, there are 4,500 seats. And section C, or the lawn, I guess, it's not C, it's L. The lawn seats, that would be an L. Lawn seats is 17,000. Just think of Ruoff, it's kind of similar there. But that's what you do. That's word problems. That is systems of equations involving word problems. Just remember, you can use the shortcut here. Using the graphing calculator, you don't have to do that one by hand. So that is it. Hope this helps.